Good morning, guys. This is going to be our the following notes on 3.03. This is parent function reflections. And so today we're going to be looking at transformations that involve reflections. Reflections are another rigid transformation. If you remember from, I think, 2 classes ago, a rigid transformation is something that moves the position of the graph, but it doesn't change the shape or the size of it. But a reflection is something that causes a function to be mirrored, and the point of reflection is either going to be the x-axis or the y-axis. Okay. And so there's 2 situations that we can have. Right? We can have a reflection over the x-axis or over the y-axis. If you notice the difference between the two, if it's a reflection over the x-axis, the negative is in front of the parent function. And if it's a reflection over the y-axis, the negative is inside of the parent function. So just keep that in mind. Depending where the negative is, will determine which way it's going to be reflected. Okay. So let's go over to example 1. So again, just like we did in the previous notes, we would say what type of function this is. This one is a cube root and the values in the table for the cube root, it was -8, -2, -1, -1, 0, 0, 1, 1, and 8, 2. So if I plot these points, I have 0, 0, 1, 1, -1, -1, and then I have -8, 2. So I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and then down 2. Give me this point here. And then I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, and then up 2. Should be this point here. Okay. All right. And then the next question is, what type of reflection is going on here? And so remember we said the question is, where is the negative happening? And let me change the color that I want to use here. I'll use orange. So the negative is inside the function, and so that means that it's a reflection over the y-axis. Okay. And what that means is the points are going to be reflected over the y-axis. So the y-axis is going to be my mirror point. So if I draw kind of a, say, a dotted line, this y-axis is going to be my reflection point. So for example, the point that was over here is going to be reflected to the other side, which would be located over here. So my new point would go over here. This point that was on the left side will now move to the right, same distance away. And this point in the center, the 0, 0, this one, it's on the y-axis, so you can't reflect this. The reflection is itself, right? The next one would be, how would I reflect this point down here? Well, however far away it is from the y-axis, if it was 8 units to the left, then the reflection would be 8 units to the right. So the reflection would be over here. And then this point over here of the parent function, if I were to reflect this, I would have to go 8 units to the left. So over here. And so let me connect this. This would be the reflection. And again, the blue graph is the parent function, and the red one is the transformation one, but it's the one that's been reflected. Okay. Let's go to example 2. Okay, so this one is asking for the same thing. What type is it? And it is an absolute value. The points are -1, 1, 0, 0, 1, 1. And so that's this point 0, 0, -1, 1, and 1, 1. And let me get my ruler. And we can set it up this way. And set up my ruler this way. All right, so that's my absolute value. And then we have to take note, where is the negative, right? Is it inside the absolute value or is it outside? And so since it's outside, it's going to be reflected over the x-axis. Reflected over the x-axis. Okay, so that means that the x-axis is going to be like my mirror. So I'm going to make a kind of a dotted line or dashed line. And so think of this as your mirror. And so if I wanted to create the mirror image of this V, it would be a V opening downwards, right? So I would reflect these points in this way. And so it's going to be the same V formation, but it's going to be opening downwards. And so let me get my ruler again. I don't like the way that line came out. All right, let me try again. Yes, that one's better. Okay. It's going to be the best that I can do. Okay, so So again, the blue one is the parent function. The red one is the reflection. Because depending on where the negative is, again, will determine which axis is going to be my mirror. Okay. So let's go on to example 3. This one is a quadratic. And so that one has the points 0, 0, 1, 1, 2, 4. So it's 0, 0, 1, 1, 2, 4. And it's a U shape, so it's symmetrical. That's the total of these 5 points here. And then the graph does something like this, right? Okay. And then next question is, what type of reflection do I have? Well, the negative is in front or outside. So it's going to reflect over the x-axis. So the x-axis is going to be my mirror. And so every point is going to be reflected to the bottom, right? Because these 5 points are on top of the x-axis. So if I make a reflection, all these points are going to go to the bottom. So that one's going to stay the same. These two would be located here, kind of like what we did with the absolute value. And this point over here would be reflected. So if it was originally 4 units up, we're going to go in the opposite direction. 1, 2, 3, 4. Here. And same thing over here. If this point was originally 4 points up, we're going to go 4 points down. Right here. And then draw the same shape, the same image. Just opening this way. There we go. And just to state it again, right? The blue one is the parent. The red one is the transformation. In this case, the transformation that we're working with is reflection. And then let's go to example 4. Okay, so here we have a cubic with the points -2, -8, -1, -1, 0, 0, 1, 1, and 2, 8. Okay, so we're going to graph the following points. It's 0, 0, 1, 1, -1, 1, and then -2, -8. It's going to go, I think it's going to go out of the window. I'm sorry about that, guys. It's going to go 1, 2, 3, 4, 5, 6, 7, 8. So it's outside of the window. So I'm just going to put it really close to, it's a little bit below, but I want to make sure we still see that point there. And then we're going to go 1, 2, 3, 4, 5, 6, 7, 8. Right here. And so it's going to look something like, And then, so then we have to figure out what kind of reflection it has. The negative is in front, so that's a reflection over over the x-axis. So that means that the x-axis is my point of reference, right? Where the mirror is going to be. And so that means that the points that were on top would be on the bottom, and the ones that were on the bottom would be on top. So these points would kind of switch places here. The one in the center would stay. The point that was down here would be located up here. And the point that was up there would be down here. And so we end up with the following graph. All right. Let's do one more. The last one is a square root. The points are 0, 0, 1, 1, 4, 2, and 9, 3, which would give me, if I plot them, it would be 0, 0, 1, 1, 4, 2, and 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, I'm going to extend it. So check. Yeah, it still stays in the window. This is the x-axis. And so I'm going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 up. Okay. All right, and then here, where is the negative? Oh, sorry, let me use orange. The negative is inside. So that means it's going to reflect over the y-axis. So the y-axis is going to be my mirror. And so all the points that were on the right side will be reflected to the left side. So that means this point would be over here, this one would be here, and this one would be 1, 2, 3, 4, 5, 6, 7, 8. Sorry about that, guys. I need to extend this a little bit more. Okay, now it should work. So let's count again. It's going to be 1, 2, 3, 4, 5, 6, 7, 8, 9, and 3 up. 3 up. It's right about there. And this point in the center stays there. And so we get the following graph. All right. Awesome. So that concludes the examples from the notes. We're going to go over this next class. And so if there's any questions, if there's anything you want to clarify, you can ask it then. But other than that, thank you for joining me, guys. I'll see you guys next class.